Let's define improper integrals with infinite discontinuities. These occur when the function has a vertical asymptote within or at the edges of the integration interval. If the discontinuity is at an edge, we replace that edge with a variable and take a one-sided limit approaching the discontinuity. If the limit exists, it converges; otherwise, it diverges. Let's evaluate the integral from 0 to 1 of 1 over the cube root of x. Here is a sketch of the function. The shaded area represents our integral. Notice the infinite discontinuity at x equals 0. We rewrite the lower bound as a, approaching 0 from the positive right side, and change the radical to a negative exponent. Integrating x to the negative 1/3 gives us 3/2 x to the 2/3. Evaluating at our bounds gives us 3/2 times 1 minus 3/2 times a to the 2/3. As a approaches 0, the second term vanishes, leaving us with a finite limit. The integral converges to 3/2. Now let's look at example 2, evaluating the integral from 0 to 3 of dx over x cubed. Looking at the sketch, we again see a vertical asymptote at x equals 0. We rewrite it as a limit approaching 0 from the right, with an integrand of x to the negative 3. Using the power rule, the integral is negative 1/2 x to the negative 2. Plugging in our bounds 3 and a, we get this expression. This simplifies to negative 1/18 plus 1 over 2 times a squared. Because a is in the denominator, as a goes to 0, the fraction blows up to infinity. Therefore, the area is infinite and the integral diverges.